I think it's time to start, and well, latecomers anyway will join in a few seconds. Well, good morning to everyone. Thanks for being with us today. My name is Bernard Lombard. I work as Trade and Industrial Policy Director at CEPI, and CEPI stands for the Confederation of European Paper Industries. And it's my privilege to welcome you to this workshop, which title is Towards Zero Waste and Resource Efficiency, Closing the Loops in the Pulp and Paper Industry. So my job is to accompany you during this very interesting workshop, which runs until 11, and to be your moderator. Well, you all know the European Commission adopted the new Circular Economy Action Plan in March 2020, and it's one of the main building blocks of the EU Green Deal, the European new agenda for sustainable growth and jobs. Don't forget the jobs. Moving towards a truly circular economy is a real challenge. We all know this, and it starts with technology. But this comes with real opportunities and new potential business models. And to better understand these challenges and opportunities, we will have a closer look at two European Commission-funded projects, paperChain and Pulp&Fuel. So I think you should see the agenda in a few seconds on the screen. Just to help you understand what we have on our program. Here we are, thanks a lot. So first, you see, I will give you a short introduction about the pulp and paper industry in Europe. And then we have these two very interesting projects. Then we will have panel discussion and a Q&A session. But before I formally kick off the workshop, let me share some important housekeeping information. We want you to engage into this discussion, and that's why you will have an opportunity to put questions to the speakers. And to do so, you can use your Q&A tool during the presentations. So we will have a look from time to time, and we'll try to take all of them or most of them during the webinar, either at the end, after the speech of each speaker, if we have time, or otherwise it will be after the panel. And anyway, if we don't have enough time, you will get an answer after the event. So we will take all the questions and then provide you with answers. Also for you to know, in the coming days, speakers' presentation will be made available on the paperChain and Pulp&Fuel respective websites. So you will get a message. I think that's it for the housekeeping. So what about the program? You have this in front of you. And as I told you, after the presentation, you will have three in a row, and we'll try to be interesting, entertaining, and keep you awake this morning. And as I told you, there is a second part. We will have this debate where we will take questions also and reflect on what was presented. One thing also we wanted to have during this workshop is some very quick surveys. And we will have a first one now, and it's about just a very basic question about who you are, because we thought, well, we can talk a lot, but the important thing is first to know within the audience. So you have 30 seconds now to answer the questions about which stakeholder group are you representing, SME, large enterprise, university, research institute, government, other, and which sector you are mainly involved in, pulp and paper industry or consulting or others. So please just answer the survey now, and in 30 seconds we will see the result. And I have to rely on the IT team here to, at some point of time, when they have enough answers, to put on the screen and share on the screen the result of this short survey. Okay, so interesting. A lot of large companies are attending this workshop. Then it's about research institutes, SMEs, and universities. So we are talking mainly today to company people, right? But I'm sure there will be some people also joining a bit later. So And then looking at the other question, well, there is a massive answer for, let's say, pulp and paper industry. So that's people who know the industry we are going to talk to, and of course, also consultants and people interested in research and innovation, I'm sure. Thanks a lot. Thanks a lot for this. I mean, that's good for us to know. Now I think it's time for me to go for my presentation. So I have to share my screen. That's where usually things happen. Hold on a sec. Then I might need some help, maybe from the IT team, because I have my slides on the screen. Can you see my screen here?
Have you clicked the button share, Bernard,
Yeah.
here on Zoom?
Okay. Share screen.
You can select the screen you want to share or the application.
You see, that's always important to rely on IT people. They know better. Okay, I think in a sec you should see my screen. Can you see it?
Yes, we can see it.
Okay, great. Good. So, yeah, I thought, well, as an introduction, I should say a few words about the pulp and paper industry in Europe and how we contribute to the EU Green Deal objectives. In a nutshell, CEPI, this confederation of pulp and paper industry, is representing about 500 companies in Europe, close to 900 mills, and it's around 180,000 people. And we have national association, but that's our internal kitchen, let's say. And we work across the whole value chain. So it starts in the forest and it goes into converting of paper. And even of some of our companies are involved in collection of used paper products. Well, EU Green Deal, I imagine that most of you are familiar with this chart, because it's how the European Green Deal is presented by the EU Commission. You know, it was adopted and presented in December 2019, and it's very ambitious. At least it is for the paper industry. Why? Because it's addressing climate, energy, recycling, all kind of, let's say, areas the paper industry is involved in. And I think it's very important to understand that the EU Commission is engaged with this EU Green Deal, and they are working on new pieces of legislation. Because as you know, it's about climate, it's about being even more responsible with resources. And of course, I mean, the pulp and paper industry has well understood what it is about. And just to remind you that in 2011, we were the first sector in Brussels here as a collective organization, I mean, to launch a roadmap for 2050. I mean, we were the first one. Nobody else has started to work so early than us in terms of industry sectors. And so we have been moving forward, saying that we will reduce our emissions substantially. And at the same time, we will increase the added value. Because all this is not about closing plants. It's about working more efficiently in a much more cleaner way. In 2019, you know, with this EU Green Deal, the EU Commission said, well, the idea now is not to reduce emission by 80%, but it's to become carbon neutral. And that's why the CEOs in our industry, let's say, launch a declaration where they say, hey, we are supporting this carbon neutral society, and we will contribute a lot to it. And in 2020, we had this industry manifesto, and where we call for, indeed, for a greener and more resilient economy. And well, it's of course related to the Corona crisis we have all experienced so far. Now, for the people who don't know, I mean, sustainability is nothing new to us. And you see a few figures. Well, it starts with turnover, 90 billion euros. you see a lot of other things. We export about, well, we represent about 20% of the world production of paper. We export more than 20% of our production. And we are a made in Europe industry, made with our fibers, with the chemicals, and everything. And the interesting thing is that over the last years, we have been investing 2 times more than average manufacturing in general in Europe. We have been reducing substantially our carbon footprint. And we have also quite big numbers in terms of, let's say, bioenergy. 60% of the bioenergy, or of our energy, sorry, is bio-based. So we are the biggest producer and the biggest user of bioenergy. And we are leader in paper recycling. And of course, we pay a lot of attention also to forest. That's why you see a figure about the certification, and we are monitoring this and trying to get even higher. Well, we are engaged in this journey, you know, to reduce emissions. And on the right end of this slide, you see, well, we are still emitting. We have still some emissions, and we are working on it to reduce this as much as possible. But the interesting thing is that, and when you have a look at the forest-based sector as a whole, I mean, one thing is the emissions, the fossil emissions we still have. The other thing is about the material substitution. When people use paper and board, then they prevent CO2 emission from other competing packaging sectors. An interesting thing is also that the forest sink is also there. It's a very positive contribution. And I mean, as you know, for years, for decades, the paper industry and the whole woodworking industry has been working on managing sustainably the forest. So all in all, I mean, we have a huge contribution to decarbonization, and we really want to further increase this contribution. I mean, all these figures can be found in a study that was made. We call it the Blomberg study. So if you want more information about this, let me know, and I can provide you with more details. Now, I would like just to give a couple of examples about what we are doing in the industry, because, I mean, we cannot just expect things to happen on their own. We have to be a catalyst. And as I said, I mean, we have reduced our emissions by 28%, I mean, since 2005. This is, the trend is there. We are still further decreasing this. And as I told you, we are a major producer and user of renewable energy. We are also aware of this carbon leakage risk, and that's why we are looking for, let's say, the best or the most cost-efficient alternatives to fossil fuels, and we are investing into this. But to have this happening, we need very innovative and sustainable solutions. So we decided already a couple of years ago to launch this Energy Solutions Forum. And it's not only about the pulp and paper companies. I mean, it's about the suppliers, energy suppliers. And we are, let's say, having from time to time meetings to exchange views, to talk about innovation. And that's really to facilitate, let's say, the exchange of knowledge. That's to identify very promising innovation stuff. And also, as much as we can, with the EU competition rules, to work on common development projects. And here, once again, I mean, we cannot achieve things on our own. We need the suppliers also, the equipment people, the machine suppliers to help us identifying this new, let's say, innovation. And, you know, we have only 30 years to go. And as people like to say, it's about 1 or 2 investment cycles away. So it's very soon. Another example, because here we talk first about the processes, here we talk about the products. We have also formed a kind of platform or forum here. And once again, that's because the pulp and paper industry cannot work on this on its own. It has to work in partnership with other organizations. And here it's really about, let's say, pushing, promoting, boosting the use of fiber-based packaging. Today, it's about 38% of all packaging brought to the EU markets. We want to increase this much more. I don't want to go too much into details, conscious about the time constraints, but it's about working on eco-design, how the product should be designed so that they can be collected and recycled easily. And then it's for us. What shall we do to better collect, recycle in our machines, in our sites? And so it's collective work as well. We have big companies involved in this work. It's a 3, 4, 5 years project. So it will take a bit of time, but we are actively working on this. And the great thing is that we see the support of many, let's say, stakeholders here. So you have the website address forevergreenforum.eu. I encourage you to have a look. Well, now you might say, okay, pulp and paper is great, but is it only the products you are considering? And the truth is that, I mean, as I told you, we are engaging us in a journey, a long-term journey. And maybe starting with the picture on the left at the bottom, the very interesting thing is that with wood, you can do a lot. You have cellulose, hemicellulose, lignin. I'm not a chemist, I'm not an engineer, so I won't go too much into details, but this is just for you to understand. I mean, with this, you can do almost everything. And that's the beauty of using wood. If you manage sustainably the forest, you have enough wood to store carbon, to produce goods that are available for everybody with a very low carbon footprint. And we developed, or it's not about developing, but we have been using this term of biorefinery. So it's a bit like petroleum refinery, but this time we are using biomass. And then with this, we make products, energy and fuels, and a lot of things. We had made a study that was launched at the beginning of this year, and we identified 139 biorefineries related to pulp and paper industry. And I mean, okay, there are some big countries with a lot of biorefineries, but I can tell you, I mean, it's everywhere in Europe. I don't want to be too long on this, but already close to 3 billion euros of turnover are generated through these biorefineries, which is about 3% of the European pulp and paper turnover. And what we see is that there is big investment in the pipe. So this is to be followed. And as I said, and I will conclude with still a couple of slides, with wood, you can produce everything. And we have classified in this study products in materials, chemicals, fuels, food and feed, pharmaceuticals, cosmetics. And it can be used in all kinds of sectors. You see this on the right, automotive, cosmetics, civil construction, and so on. So, I mean, the pulp and paper industry will go ahead with pulp and paper products, that's for sure. But thanks to this biorefinery, we are just being more, resource efficient. We are using more and better the wood we consume today. And that's really very important because it will help us to reach also this target of increasing the added value in the sector. One thing I want to address, to draw your attention on is these man-made fibers. You know, with cellulose, you can make indeed textile fibers. And it's a very promising market, and it comes also as a potential substitution to cotton, for instance. So we are working on this. It's, you can believe me, a very interesting industry to work in. Now, the last slide, I think. All this can only happen if we have a policy supporting this shift to low carbon and circular bioeconomy. We heard about the EU Green Deal objectives. Well, I mean, it's very important to listen to the industry because it's only together that we can do this. And our ambition is really for us, the pulp and paper industry, to become the hub for the bio-based economy. We have this vision, and I think we share it with the EU Commission. And that's really the way we want to contribute to the EU Green Deal. But once again, we have to invest billions of euros in the coming years, and not in 2049. It has to be done already today. The forest strategy, I finish with this, is going to be very critical. How to find the right balance between conservation of forests, the carbon storage, but at the same time also allowing the use in a sustainable way of wood to produce, let's say, low carbon footprint products. Okay, I stop here. Thanks a lot for listening to me. I think now I have to stop sharing my screen. Here we are. And then it's time now. I don't see any question on the chat, so maybe later. Now it's time to move to our first project presentation. And this is Geert Haarlemmer. I hope my pronunciation is okay, Geert. Yeah?
You're fine.
Speaking, but I do my best.
Yeah.
And Geert is the coordinator of the Pulp&Fuel project. He has more than 10 years experience working with CEA, as we say in French, or CEA in English, on biomass conversion projects. And he will introduce us to the Pulp&Fuel project. Geert, the floor is yours. Thank you.
Okay, thank you. I'll present my screen. Tuck. Do you see my screen?
Yeah.
Okay, perfect. So we're presenting the project Pulp&Fuel, which EU project that started in 2018, I think. It's the project we're looking at waste that was generated by the pulp and paper industry, or the pulp industry in particular. And we try to show that how we can integrate the gasification technologies in this industry. So in the presentation, we'll talk about the pulp mill, gasification technologies, fuel synthesis, our process design and process evaluations, and then we'll try to present some conclusions. The project is halfway, roughly. We're month 30 of a 48 months project, so there's still some work to be done. The biorefinery or the pulping process is a biorefinery, as Bernard already mentioned. Basically, we separate, we refine trees. So we produce bark which can't really be used in the process. So we burn this bark to produce heat and CO2. The wood itself is separated by a chemical separation step to produce cellulose, which is the part which is most valorizable in the woods to produce paper. Sugars and in particular lignin that's contained in the woods is removed from the wood by a cooking process. It's stored in black liquor with cooking chemicals, and these cooking chemicals are recovered by combustion and producing CO2 and of course regenerating the cooking chemicals. So it's supposed to be a closed loop, except of course that we reject a lot of the carbon that's in the trees as CO2. Now, the paper industry has a lot of challenges in the next coming years. Reducing CO2 emissions is very important, even though there are biogenic CO2 emissions. It's biogenic carbon which we're injecting. In practice, it's still worthwhile not to reject them, and we can try to make high-value products out of these carbon components. There's some pressure on the EU paper industry is generally doing okay, but there's still some pressure, general pressure of all industries. And in particular, there are a lot of bottlenecks in these in industry, and it's the main bottleneck on most pulp mills is the recovery boiler to destroy the lignin and to regenerate the cooking salts. So there's a lot of ways of diversification. Valorizing lignin, this would allow us to reduce the carbon load on the recovery boiler. We can also look at valorizing sugars that are contained in the wood and that are liberated during the cooking process. And of course, we can use reuse waste products such as bark. Now, one of the more concrete projects that are going on are, of course, biofuel production to integrate gasification technologies on a pulp plant, which are fairly well-known technologies, but still take time to develop. There's also a lot of projects on lignin extraction on this to remove the lignin. Another interesting pathway is to pass from craft cooking to soda cooking. A traditional process uses craft cooking, which is based on sulfur, which recirculates a lot of sulfur in the plant, and of course leads to small sulfur emissions from the recovery boiler and other parts of the process. And soda cooking allows us to perform the cooking without any sulfur. And of course, this is something that's well known for a long time. But to have a very efficient process, we need pre-hydrolysis, which produces sugar as a byproduct, which are interesting because they also reload. We send less sugars to the recovery boiler to be burned, and we can valorize the sugars. Sorry. So just a small recap on the project. It's a 4-year project, 10 partners. They're situated in Norway, Sweden, Switzerland, and France. It's a 4.9 million euro project, and I'm the coordinator. There's a website where you can find more information. Small word on our laboratory. We are in the hydrogen and biomass laboratory at CEA, which is part of LITEN, which is the new energy innovation on new laboratory on innovations in the technologies of new energies. We look at, in the department, we look at electrolysis, CO2 valorization, and of course thermochemical conversion technologies for biomass and others. And the main objectives are to produce carbon carriers and hydrogen for new ways of new mobilities. Of course, either to produce liquid fuels or to produce hydrogen or even mobility with fuel cells. The Pulp&Paper project, what's this? Okay, the pulp and paper industry is essentially a biorefinery that has the advantage of producing very large amounts of material. It consumes a lot of material and it produces a lot of material. This is so they have an infrastructure in place. Everything is already well organized, which is different with some other biorefineries and biofuel production, where everything needs to be done. There's no infrastructure in place. So basically, the two main products are byproducts are bark and of course black liquor from the cooking step. And generally, these wastes are recycled or as a fuel, as a low quality fuel, or are burned. And at the end of the day, it's even if this combustion produces energy, it's still very expensive. So the project will try to demonstrate synergy between dry gasification and hydrothermal gasification by showing that these two gasification pathways produce different qualities of gas, and they're very complementary. So we can show how we can this complementary and show how we can efficiently produce biofuels as a co-product of the pulp industry instead of producing heat and bark. And of course, we'd like to prepare the ground for a demonstration plant, which is the ultimate goal of the project. Now, if you saw, I presented the craft cycle before, or the classic cooking cycle. So what we try to do is to include gasification on the bark, dry gasification in a train flow or a fixed bed gasifier to produce hydrogen and carbon monoxide. On the black liquor, we try to implement supercritical water gasification or hydrothermal gasification to recover the chemicals and to produce a gas which is rich in methane and hydrogen. And both gases mixed, they can be used to synthesize fuel in Fischer-Tropsch process. Oops. There's okay. Sorry. There's basically on gasification. We tried gasification consists in a lot of steps. First step is of course drying. Devolatilization. So all the organic molecules are separated in char and volatile components. These volatile components are reformed in the gas phase to form hydrogen and carbon monoxide, and of course also CO2. And the char is gasified with oxygen or water vapor to produce also CO2. No, this is combustion actually. It also produces with oxygen. Actually, in partial combustion, you can produce carbon monoxide. There are a lot of technologies: fixed bed, fluidized bed, and train flow. So these fixed bed and train flow will be looked at in the project. And on the hydrothermal part, we look at supercritical water gasification, which is an alternative pathway which is particularly suited for wet resources. This is the fixed bed gasifier, which operates at RISE ETC. They've done about 30 experiments in this gasifier on bark, particularly on two types of bark, softwood and hardwood. And they've actually shown that they can produce a very good quality syngas with this gasifier. At CEA, we work with a train flow gasifier, which is operates at much higher temperatures and pressures, which has the advantage to produce a slightly higher quality syngas, but of course at the price of a slightly higher complexity. So a lot of experiments are done on at CEA with this gasification unit. And then a third gasification unit that's used in the project is the supercritical water gasifier at CEA, where instead of using a dry resource like bark, we inject black liquor directly in the gasifier, which is preheated, and then it's sort of like a spray. It leaves the gasifier, and then it's gasified at very high temperature at very high pressures. We're typically at 300 bars, and of course the temperature is a bit lower than in train flow gasification, mainly because of technology reasons. So we're supercritical, and the advantage of supercritical water is that we separate the salts relatively efficiently. So we have one phase which contains a lot of gas, a lot of water, and the product gases, and one phase which is liquid, which is with a concentrated brine with the cooking salts, which can then be recycled. Typical gas compositions produced from gasification are as expected. In dry gasification, we produce a lot of carbon monoxide and hydrogen. Now the technologies between the racks are slightly different. We have a water quench at the bottom of the train flow gasifier, which induces a lot of water in the system, which by a reaction called water gas shift shifts the composition between carbon monoxide and hydrogen. Which we don't have in the fixed bed gasifier. So this explains the difference between the two. But essentially, the gas is a mixture of hydrogen and carbon monoxide. And of course, there's always some methane and carbon dioxide. Wet gasification is totally different. It produces a lot of hydrogen, but it doesn't produce any carbon monoxide because of the very large amounts of water that are present. This carbon monoxide is shifted towards CO2 and hydrogen. And an additional gas that's being produced is this methane. This cannot be avoided because it's when you have hydrogen and large amounts of carbon monoxide or CO2, you always produce methane. So the two syngases are joined are first separated differently. So first cleaned differently because of the different compositions. When we use craft black liquor, there's a lot of sulfur, so we have a sulfur recovery unit, which is quite important. And then we have to remove the carbon dioxide and some traces of the sulfur to then follow with pressure swing absorption. We produce pure hydrogen, which can then be used in the synthesis. From the dry train, we have the syngas can be shifted directly to remove some of the carbon monoxide to adapt the hydrogen to carbon monoxide ratio, and then cleaned by an amine unit. And then, of course, the sulfur is recovered in the sulfur recovery unit. It can then be re-injected in the craft process. And then both syngas streams are mixed together and used in the fuel synthesis. The fuel synthesis is actually a two-step process. So the advantage of having two qualities of syngas available in the process is that we can have a two-step reactor, where first we have a mixture of hydrogen to CO, where we produce actually the Fischer-Tropsch reaction is very simple in itself, because it just combines CO and hydrogen to form liquid fuel. But depending on the ratios, you can either have high conversion and low chain lengths, or low conversion and high chain lengths. And by having a little bit less hydrogen in the first stage reactor, we can actually favor long chain lengths at the detriment of conversion, and then adding a second reactor with a second injection can actually increase the productivity of the plant. So there's a real synergy between the two reactors with the rest of the system that produces two different qualities of syngas. And typically Fischer-Tropsch produces paraffins, relatively long paraffins, and some small amounts of olefins and alcohols. But the main product is long chains, something like in the C15 to C30 range. So they're like waxes that then need to be upgraded into liquid fuels. But this is something very well known. This is something done at a very large scale in Qatar and in the Gulf of Arabian Gulf, because a lot of gas to liquid plants are based on this technology. The process design is a task that's done by EPFL. So basically, the whole system is modeled, and so with all the energy, energy streams, fuel streams, CO2 streams, and the modeling identifies the main energy users in the system and carbon emissions, which are of course the bark boiler, which produces energy and CO2, and of course the recovery boiler and the black liquor concentration. These are the elements of the plant that uses the most of the energy. So how we can valorize the resources in this in the project? So in the industry, because the modeling is part of a much larger optimization system, which uses different pathways we can use, different sizes, different operating conditions, performances, effects on the plant. And the idea is to produce a model and a decision tool to optimize the integration of gasification technology in the refinery. So the process is it starts with an analysis of the problem, generation of the models, evaluation, and then we integrate. So we start with process modeling, definition. The process optimization uses the model and with a lot of decision parameters that have been defined by the project. Then there's a relatively complex system that integrates and optimizes the process with a lot of decision variables. And this is something that's actually this is domain of EPFL and they do a lot of projects on any type of industry actually. And it produces typically spaces with decision variables where we can have each pathway is a line, and we can color code the different pathways and the efficiencies. And So each this is one of the each out product each model result is actually a line in the is actually a point on this, and they're all linked together by a line for one case. Then we get Pareto fronts where we have where we can have the trade. We can see the trade-off between the project result and the investment. So this is a Pareto font on 2 different parameters, but of course we can have much more. So if you have 2 objectives, then it's no longer possible to have one pure optimum. So for example, here we have different, the capex is an objective, operating costs are an objective, emissions can be an objective. So there can be a lot of objectives. So we have a small case study. In this case, I present a small case study. There are a lot of, it's actually something that's going on at the moment. So we have the basic scenario 0 is the traditional case. Scenario 1 is the scenario where we include dry gasification, and scenario 2 is where we have both gasification trains. So some preliminary results of this, that we have the 3 scenarios here. So we can see that the first scenario, we don't produce any fuel, FT fuel, we produce electricity. We have relatively low operating costs, and we have high greenhouse gas emissions. And the other 2 scenarios, we have, of course, more fuel production. We don't produce any electricity, higher investment costs. So, so all these scenarios can be evaluated, and from a purely CO2 emission and economic perspective. So now we're looking at the sustainability, which is also can also enter in the optimization problem. So I'm hoping not using too much time. I think I'm in time. So we're looking at the qualification of the verification of the feedstock, environmental and social sustainability, and of course risks and opportunity of the project, of the concept. The feedstock, it's okay actually, because it's already labelized for the RED 2. It's more or less fulfills all the criteria as being a sustainable feedstock. So so this is okay. We don't have any constraints on the fulfillment of land use criteria. And apart from that, it's perfectly suitable for renewable fuels. On the environmental and social sustainability, these are actually evaluations that are currently going on. But actually, I'm not very well prepared on this. But basically, what we can show is that the greenhouse emissions are relatively low, and because they the concept actually produces very efficient reductions on greenhouse gas emissions. This, of course, depends also on the electricity mix you use for the evaluation. And in this particular case, we use the French electricity mix, which is 80% nuclear. So this helps, of course, in the decarbonization of our liquid fuels. It would be different as if we use electricity mixes of other countries. But generally, it's a very encouraging way of. It's actually quite encouraging. It's possible. I think we should be able to attain our objectives on this thing. Risk opportunities. It's actually this is always a complicated exercise, but basically it's feedstocks require only high I think generally we're quite good on the technologies, on the opportunities that we have. It's just that, of course, there are a lot of there are always threats to these things. If the RED 2 directive changes, or if it becomes a RED 3 and it shifts some of the compliance of the resources, this is going to be a problem. And of course, there's always a risk of being of having the wrong resources and having the wrong situations. But generally, it's relatively good. It's relatively promising. So in conclusion, I can say there are no the advantage of this of our approach is that there are no shortage of resources. As long as we can show we can integrate the technology in the process plant, in the pulp plant without costing them too much heat, then it's okay because they need a minimum amount of heat. But there's no real problem in on the resource side. Dry gasification is something that's mature and works. It works. It's just that there's great difficulties in developing because it's economically difficult to compete with traditional pathways. But it's the technology is there. Supercritical water gasification is not quite mature, but it's getting there. There are more and more actors in the field that are proposing technologies, and it'll take a little bit longer to develop than dry gasification, but it's going to be there. And but basically what we're showing in the project that the concept makes sense. Basically, we can have two different technologies operating on one plant, one complementing another, and being integrated without damaging normal operation on the pulp plant. There's an imbalance. There's a small problem in the imbalance in the capacity in the supercritical water gasification. It appears to be difficult to make very large supercritical water gasifiers. So this is something we're still looking into. And so it's possible that we also look into alternative hydrogen projections to complete the integration. Okay, this is it for me. Thank you for your attention, and I'd like to give the floor back to Bernard.
Bedankt, Geert. Bedankt.
Okay, graag gedaan.
To you.
So stopping my presentation.
Yeah. Was very interesting overview and very promising project. And we will have the occasion, of course, to hear more from you during the panel session. You see, I mean, I talked about biorefineries with very simple words, but I think thanks to you, then people understand it's a lot of technology, research, and there is a need for innovation. But I mean, the promise is there, I think, and that's fantastic work. Thanks a lot again, Geert. Now we move to the second presentation, and that's the turns of David Blomberg Satan, who is working as Director for Research and Development in RISE at the Department for Biorefinery. So now he will take us through the paperChain project. David, floor is yours.
Yeah, thanks, Bernard, and good morning to all of you. I think Antonio, you were about to show some film. Can you hear me?
Yeah, sure. We can play it right now. Yes, please, Nicola.
Yeah, just give me 1 second.
Perfect.
The European pulp and paper industry has a challenge, keeping the production of paper and other cellulose derivatives eco-friendly. For decades, the sector has been adapting, developing new recycling practices and efficiency standards. Still, it is possible to do even more. This is why Project paperChain was born. 20 partners from 5 European countries working together to find new uses for the non-hazardous wastes of paper production. A new step towards the zero waste goal, because circular economy is the key to a sustainable future.
Thanks a lot for the help. Now I'm trying to share my screen, so hopefully you see something now.
Yeah. Yeah.
Perfect. Now even bigger. So thank you a lot for this. Thanks for the help with the film, and thank you, Bernard, for the introduction. So I will give a short overview of the paperChain project in all, and then I have a deep dive into CC4, one of the circular cases. So I will go through the different steps in that circular case, and also describe a bit about the involved companies in this CC. But starting up, I will describe a bit about the different circular cases that we have been working on in paperChain. So as you saw in the movie, there are quite a lot of material that goes to landfills today. And this project, the paperChain project, is handling those type of residual stream from the pulp and paper industry, trying to use them in other types of application and other industrial sectors to, in the end, remove all the residual stream coming out from the pulp and paper mills, and to have this secondary raw material to be used in other sectors. So just a snapshot of the companies involved in the project. So thanks to all of you, companies and research organizations. Been a great group. Thanks. So I start off with then the circular case 1 in Portugal, Aveiro. So here they have actually a few different types of materials like lime mud, slate grits, and green liquid dregs to be used as additive in asphalt and also in precast concrete. So I will be very short on this. So here you can see some, I do like this, sorry. Here you see some different manufactured roads within the project and some precast concrete beams. So to CC2 in Spain, Zaragoza, and Valencia, but they use ash, and it's a ash from waste paper incinerations. So you use that ash as a stabilizer of the soil in road projects. CC3, it's in Slovenia, and it's a landslide close to the railways. So they have prepared a material called Mudipel, where they stabilize these landslides and actually can save the railways if you have that kind of problems. CC4, this is then the project that I will describe a bit more in detail, but this is in the chemical sector using fiber rejects and producing at the end a cellulose derivative called Bermocol. It's a cellulose ether. And the final one is CC5, and it's related to green liquid dregs that is used as a part of the sealing layer in covering up mine tailings, sulfide-bearing mine tailings, to avoid water and oxygen penetration into this waste rock and avoid leaking of metals into the environment. So that was the cover of the whole project. Now I turn to circular case 4, then the chemical sector, and I start off with this picture. It's a picture of the industrial site in Örnsköldsvik. So I can point in the foreground here. You can see the Domsjö Fabriker. It's a pulp mill where they produce cellulose for the viscose industry, and they also, from the hemicellulose part, they ferment that to ethanol. And then they take the lignin, either you burn the lignin to recover chemicals and produce steam for the process, or they actually also have a spray drying unit down here to have the lignosulfonates isolated. And then we can go to this part of the picture where we have CEPI and Nourion. Starting off with CEPI, it's a chemical company that prepares ethanol derivatives. And today they are producing acetic aldehyde, acetic acid, and ethyl acetate. That is 3 main products from them. And they are actually situated a few meters from Nourion, the red buildings here. And Nourion is producing then a cellulose-based thickener and emulsifier for paint and construction material. I represent the Processum here as a part of RISE, and we sit in these facilities over here. So it's a very integrated system. And actually all these 3 producing units, Domsjö Fabriker, CEPI, and Nourion, are located at the same industrial site. So I will go for the next one. So this is an overall picture of what we have been trying to do in the circular case 4. Everything that is marked in black, that's already existing processes and products coming out from this area. Everything that you see in blue is what we have been investigating during this project. So the blue ones are new processes that I will try to describe in a bit more detail. I will actually come back to this picture to have everyone to see the full picture. But we start off with the enzymatic hydrolysis. We have the fiber reject and like this. So we have the fiber rejects. It's actually 2 different types of fiber rejects. It's not reject and fines. So in that case, you have polymeric sugars that you feed into a reactor for hydrolysis, and you add a mixture of enzymes to this reactor, and then you prepare a monomeric sugar stream that is then fermented to ethanol by yeast. And I can add also here that this area here, we only use softwood, and the softwood hemicellulose part consists of a majority of hexoses. So it's more or less traditional yeast that's used in this fermentation. After fermentation, a purification via distillation unit, and the output stillage that goes back into the black liquor and continues in the mill. So what we have been investigating in this project is in this red square that you can see here. It's using the fiber rejects and preparing a sugar stream that is fermentable. This part is already existing at full scale at Domsjö Fabriker. So here you can just see some picture from the demonstration equipment that we used in the hydrolysis. So this particular residual here is the not reject. And after hydrolysis, you can see it's a residual of the knot from the tree. Actually quite nice material. So then we take the next part of the project that's actually then producing a pulp or a cellulose that is suitable for production of the cellulose ether Bermokol. Today, Domsjö Fabriker is producing a dissolving pulp mainly used for the viscose industry. So we have to alter the conditions and find a new way to produce this cellulose, because the specification and the properties are different if you're going to use the cellulose for cellulose ether production, Vermocol, or if you're going for the viscose production line. So in this case, we have started off with a pilot scale tests to find the new condition, both for the digesting step, but also for the bleaching step and so on. And these pulp were evaluated then at Nouryon at the pilot plant they have for Vermocol production. So we could find a suitable quality that could meet the specification from Nouryon. And actually in this case, we also prepared 7 full-scale cooks in total. So we have these consecutive cooks. We altered I would say mostly we altered the residence time between the 7 full-scale cooks, and we took out samples then for evaluation at Nouryon as a raw material for them. And can also say that the pulp viscosity is very important for cellulose ethers, but also other variables like brightness and kappa number and the amount of hemicellulose present in the samples are important. So then for the next step, and that's the ethyl chloride production. As you can see here, for production of Vermocol, ethyl chloride is one of the components needed. Another one is sodium hydroxide, for example. So the ethyl chloride production from ethanol as a starting material. And of course, the ethanol comes from Domsjö Fabriker to CEPI, the chemical company, having the goal actually to prepare the ethyl chloride for the production of Vermocol at Nouryon. So I have really simplified the process flow diagram here. So you have ethanol as the starting material, you have a dry HCl gas, and you feed that into a reactor system containing a catalyst. And there you have the reaction, so you form ethyl chloride. And we have also actually a pump here for sodium hydroxide to adjust the pH to not destroy the equipment that we have downstream here, because HCl is a really corrosive reagent. So you have a distillation where you remove the ethyl chloride. The bottom product from this column goes down to another distillation column for recirculating the excess of ethanol that is used in this process. So just for showing here, this is the PNID that we have taken forward and used for building up the demonstration unit. So here you can see like the HCl gas tube, you have the reactor here, you have the first distillation column, collection of the material here, and regeneration of the ethanol in this column. So this is quite complex. And also for the next slide, I can point out also that we have a sample where we can take samples. One is after purification in the distillation column, and one is actually directly after the reactor. The reactor is here, so we have no purification here. So this is the crude material directly out from the reactor, and this is the purified stream. So in real life, the equipment looked like this. So here you can see it's the easiest way is to look at, you have the reactor sitting up here. You have 2 columns like this. This is for purification of ethyl chloride, and this one is for regeneration of the excess ethanol. So yeah, the remaining work, and actually I didn't say that, but this project is soon to be ended, and the final work we have done here is fine-tuning of the process. So we're looking upon the flow rates, ratios between the HCl and ethanol. We're looking at different temperatures, and we also have done distillation trials, and also in the absolute end here of the project, we evaluated different types of catalysts as well. So this is a table with some of the results. And as you can see, if you take a sample directly of the reactor, we have a purity, well, ethyl chloride is, well, 53%. We have some diethyl ether formed as well. If two ethanol molecules react with each other, you get diethyl ether. We have some excess, the residual material, ethanol also still present, and we have water. Water is formed in a reaction. And of course, we have some unknowns as well. But you can see after a purification step, we can reach actually quite high purity numbers. And this diethyl ether as the main contaminant, I would say, in this stream, it's an inert solvent that actually is, to some level, it's perfectly all right for Norion to have this kind of contaminant in this for their process. And this last highlighted entry here, that was a collected sample from 25 hours run. And that, I would say, is the first well, long-term operation, really to get the feel of like fouling of the catalyst, other types of long-term problems that could arise. And of course, 25 hours is not enough to build a full-scale plant upon these results, but it at least is the first long-term operation that we did. So the final part then at Norion, production of Vermocol. So that here you have a picture of the pilot equipment that they have at Norion. And it's several steps. It's grinding, you do the reaction, you neutralize everything. So because you add sodium hydroxide in this step and you neutralize it, you dewater, you grind it, you dry it, and in the end, you also sieve it so you have the product out, the Vermocol. So from these tests, we have done some evaluation of the produced material within the project. And as you can see, most of the specifications are met when using the materials from the project. I would say that the gel content is the only one sticking out, and that is probably due to unreacted cellulose building up small lumps. So it's something that needs to be addressed further in research if you're going to end up being able to use the cellulose quality in the Norion process. So as a summary, ethanol production from the not rejects and fines, that has been a successful trials. We produce the monomeric sugar stream, and the sugars are it's a fermentable sugar stream that we produce. The cellulose for cellulose ether production, we have the pilot scale trials and scaled up to full scale trials, which I think is really fantastic actually. So we had this full scale trials performed and evaluated the new cooking digesting conditions that we found in the pilot scale. Samples were taken out for test and evaluation in the Norion process. Ethyl chloride production, demonstration rig is constructed, and one point that is really important, handling like hydrochloric acid, for example, is the safety assessment work that we have done in the project. And that has been a massive work on that actually, and it's been all the involved companies have been participating in the safety assessment. We have done a lot of tests with different feed rates, different molar ratios of the HCl and the ethanol. And in the end, as I mentioned, we have evaluated different types of catalysts as well. And one, first long-term operation test for 25 hours was also performed. And then we have the Vermocol pilot production, where we evaluated the wood-based cellulose for this cellulose ether. And of course, we have the analysis and evaluation of the produced Vermocol, as I showed on the last slide. So with that, I would like to thank you all for listening, and I will be happy to answer questions later on. Thanks.
Thanks a lot, David. Thanks a lot. I mean, I must say it's quite fascinating what you have shown us, because it's really about the combination of different activities and different companies on the same site. And all this work together, the residues of the waste of one actor is the raw material of another one. And this is really a fantastic way to increase resource efficiency, and through innovation, there is fantastic things that can be achieved. I see there is a question on the chat, on the Q&A, sorry. So I can take it because we are a bit ahead of schedule, and then we will move to the panel discussion. So I will try to answer the question, and then it's up to anybody to take it. One thing is about, how will the pulp and paper sector secure enough funding for the transformation to carbon neutrality? Okay, I will try to give an answer, and then it gives a bit of time for the others to think about what could be the answer. And anyway, I'm sure it will be part also of our panel discussion. I think the first thing is that we have to be aware there is some funding available, and that's part of the EU Green Deal. We know that a lot of things can happen, but they need funds indeed. And often we need to de-risk. We need someone to put a bit of money so that others can engage. And I think it's the role of the EU Commission, its agencies, but also at national level. There is a need to, let's say, initiate, let's say, the funding. And of course, I mean, private money is needed. Nobody questioned this. A lot of private money is needed. And I must say that, I mean, the best way to secure that we have enough funding is to come with great projects. And I think what we have seen here today shows that there is huge potential and big opportunities. So if we are able to show that the paper sector is really engaging in this long-term journey, the money should be there. But of course, I mean, there is a need of a bit of support from probably the public authorities to help us launch the project. And I'm quite confident that for a good project, there is always good money. Now, I turn to, without starting the panel discussion, but is there anybody else who want to add something to this? No? Okay, so anyway, it gives some time for people to think about the panel, about this for the panel discussion. So as I told you, now it's time to open our panel discussion. So David and Geert are with us today, and you can put your camera on. But we have also Yasmina Dkhissi, Amaia Sopelana, and Juan, José, Cepriá. So maybe if you allow me, I would like to give a short introduction about starting with Yasmina Dkhissi. She is a sustainable innovation strategist with LGI. She leads the exploitation work package for the paperChain project. And she has over 10 years of experience working with international stakeholders and to help deliver innovative solutions to today's climate and sustainability challenges. Amaia Sopelana works as a senior researcher and business innovation expert in building technologies division at Tecnalia. She is actively involved in technological innovation management for about 17 years. And this is in the manufacturing and construction sectors. She's an expert in new product development process, business model innovation, circular economy, technology transfer. And she's the leader of the work package design of the novel circular economy models for the pilot cases for the paperChain project. And last but not least, Juan José Cepriá works as Acciona. I hope that's the right pronunciation, sorry for this. construction technology center. So it's based in Madrid. And he's a R&D project manager. He has been involved in many waste valorization projects worldwide. He's working on strengthening relationship between the industrial and the construction sector for the mutual benefits. And he's covering research to business development with the aim of producing more sustainable infrastructure. And in this context, Juan José has been a project coordinator of the paperChain project you have just heard information about. So, I mean, you understand that during this panel discussion, built on what we have heard, we will talk about competitiveness, circular economy, and the use of paper manufacturing residues. And with one thing in mind, the zero waste objective. Before we start the panel, actually, we would like to just to secure you're still with us, okay? And go for another survey. So you should see it on screen in a moment. So now it's about technology, guys. I need you. Okay, so the question put to you, what dimensions do you think are the most critical to adopt circular economy models? So you can select one or two or more. So now it's your turn, please. You have 30 seconds, thank you. And then the IT system will show, as soon as there is enough answers, you can show the result. And I'm sure it will inspire us for our panel discussion. Aha, okay. So what dimensions are the most critical to adopt circular economy models? So policy regulatory, 60%. That's huge. I think it's really part of the issue. Second or third, I mean, they are at the same level. It's about technical stuff and economic and finance, and of course, innovation. But first, I mean, we need the regulatory environment to be supportive, and then it's about techniques and finance. I think that's what we could expect, and at least that's what I expected, to be honest. So thanks a lot. Okay, now time for a panel discussion. So don't hesitate, of course, to put your question on the Q&A part. Well, maybe I will start, if you allow me, with a question. So we have 3-4 questions, but I'm sure we will have also some from your side. Listen to David and Geert. Both projects are examples of real-world applications. Now I would like to turn to challenges. What are the main challenges you have faced over the project lifetime? So what are the main challenges you have faced, and what could be the main benefits for industry and society? What can we expect? So it's 2 questions in one. Who wants to start? Juan José, maybe?
Hello, Bernard. Hello, everyone. Yes, I can break the ice if you prefer. Well, I can give a general. I can answer your question from a general view of the project. As you know, paperChain covers 5 different models. So 5, maybe 5 different approaches in some way, but with a common result. I would say in general that the main problem we have had to face along the project has been related with logistics. paperChain departed from a relatively high technology readiness level. And the aim of the project was to end up with a high TRL close to the market. So this implies to have pilot demonstrations at a real scale in operative environments. So this implies a logistic challenge because the host of the infrastructure we use for the pilots are active. So we had to combine a tight, strict schedule established for the European Commission for the project with the real operation activities of the different companies, and of course many other problems that arise during the project life, from simple weather conditions to the COVID. So we have had many problems to deal with these logistics. But well, finally, I would say that we were able to solve anything, and the pilots were successfully built in all the ways. So yeah, fortunately, we have count with the support of the European Commission to understand this type of changes on the schedule from time to time, and well, everybody has helped to make this happen. And well, the main benefit, I would say that probably the main benefit is to produce examples for others to replicate these technologies in real conditions, in real operations. So of course, the situations change from one place to another, from one company to another. The economic, social environment changes from one country to another, even the regulatory framework. And all these cases must be adapted. But you can see, reading or looking at our case studies, you can get ideas, impressions, the problems we have had in this operational conditions. So that would be helpful for others too. So I think this could be the main benefit for others.
Okay, thanks a lot, Juan. Well, people who have been in paperChain, well, Yasmina or Amaia, do you want to complement what just Juan said? Anybody?
Yeah, yes. I think I definitely agree with what Juan José was saying, and of course I think this goes back to the importance of being pioneers in this field and really demonstrating those solutions that can help. Well, in the long term, and hopefully in the shortest term possible, to tackle the sustainability and climate challenges that we face. So I think it's definitely key to have those projects that can be helped with public funding to demonstrate and to identify what barriers can be faced, to also provide initial solutions to those and recommendations to those barriers that can help others on the journey, that can also help build partnerships with other organizations and with the industry in general, and then perhaps with a broader view on the benefit to society. These are indeed solutions that can help lower the carbon footprint in the long term. So I think overall benefits to health of the planet and the people among.
Thank you. I don't know whether Amaia, you want to add something, or and then
yeah. Well, just something to add, a short comment that yes, I agree with all the comments from my colleagues, and of course just to highlight that the way partners have been working on developing and creating and designing the circular business models has been really satisfying, and they have learned a lot, and the way they have changed the mind and how the collaborative efforts could help us to the transition towards these create added value new products.
Okay, good. So I don't know whether Geert, you want to add something here.
Yeah, We actually had a quite different experience, of course, in concerning difficulties and potential benefits for society. At the start of the project, or when we created the project, we had a particular technology in mind for the cooking process of wood, which is called soda cooking, which is a sulfur-free technology, which is based on the pre-hydrolysis to remove sugars, and then there's a cooking on with purely sodium hydroxide, which doesn't contain any sulfur. So the only sulfur in the plant will be traces of sulfur that's always contained in the wood. And of course, when we started the project, the operations people in our paper mill partner Fiber Excellence, they said, "Hold on, guys, this is all very interesting, but what we really need is to have this to work on the craft cycle, so containing sugar, sulfur." Which of course changes a lot in the gasification of black liquor. When there's a lot of sulfur in it, it produces hydrogen sulfide, which of course is a very toxic gas. So this sort of made us change a lot of ideas and made us think a little bit about how to adapt this technology on the actual craft mill. So it's possible, of course, but it's at a certain cost of a certain intellectual activity. But in the long term, I think it's something that's because generally the soda cooking process is slightly less efficient than the craft process. It needs additional steps, but it does have the possibility to produce sugars that can be used elsewhere. And it is objectively something that could be interesting. And the gasification, even though gasification is more difficult on the craft, it's actually something that's very interesting in the soda process. And the soda process has the advantage, of course, being slightly less polluting because there's no sulfur in the plant. So generally, I think the society or the environment can benefit, not so much society as is, but the environment can benefit of a popularization of the soda cooking process.
Okay.
And this can be helped by the gasification technologies that are more adapted to this. So this is something I can see, something which is a difficulty in the process, in the project, which of course is obvious as soon as you're in your office at a research institute, and then you set up the project, and then you start talking for real with operations people. Then of course you're saying, "Hey, hold on, guys, this is not how we do things." But I think it's something that that might, in the ideal case, might help the development of alternative cooking processes that are environmentally more interesting.
Okay, thanks a lot, Geert. Another question to maybe to David, but so I mean we have seen, or I've tried to show that the pulp and paper industry has been working on its sustainability, and I think it has been quite successful in reducing its carbon footprint over the years. Of course, I mean we are not there yet. It's not 100% sustainable, but we are working on it. The point is that we know that the challenge is there. I mean, carbon neutrality is a big challenge. Zero waste is a big challenge. So we know that it cannot be business as usual. We have to accelerate the whole thing. It's not, we heard, I mean, there are challenges, it's about money, it's about technology and so on. So the question to you maybe is to start with, David, I mean, can this train accelerate? Can we go even faster? And then the other question related to this, I mean, do we have to wait 5 years, 10 years to see this accelerating, this trend, or what do you have in mind? How do you see the next, I don't know, 5 to 10 years?
Yeah, I can start off by going back 10 years when I started in this business, the pulp and paper and the research business. When I was talking to the companies 10 years ago, the questions were different. And I would say, of course, depending on what company you talk to, but a lot of the companies are actually setting strategies, setting up hubs at the companies where people are working directly with this kind of like circular economy, or reducing the amount of this residuals material falling out from the process everywhere in the process. So one main focus is to reduce the waste problem, reduce the handling problems of waste, and the other one, reducing the carbon footprint. So I would say that they are looking upon replacing then fossil fuels in all the combustion units that they have, all the like the lime kiln and so on. They are replacing fossil-based oils with either you have pellets or you have bio-based oils, also originating from the pulp and paper industry, like tall oil pitch or something like that. But I would say that they are working both on closing the loop much more now than 10 years ago when I started, and they're also looking upon having like I've heard they discuss like fossil-free transportation, both to and within the industry. So they are absolutely looking upon different actions that they can have to reduce the carbon footprint and to reduce also the environmental impact from the other residual streams. So that there are like SMEs filling the gaps also, I would say, where the big companies not are working. You have SMEs filling these gaps, like how to handle biosludge, how to prepare something out from ash, and so on. So we have a couple of examples where they're actually gone very far to full-scale implementation of new techniques at the pulp and paper mills.
Mm-hmm. So in a few words, do you see this trend accelerating, coming back to my question? So you really see that things are coming up.
The mindset of the pulp and paper industry is, at least to my experience, that it has changed over the 10 years that I've been working, and I see this is a really hot topic for them to solve. So I would say it is accelerating, and hopefully we will see also results coming out from that.
Okay. Geert, we talk about, or I heard David talking about transport. How do you see this? I mean, the impact of transport and the use of these fuels in transport. I mean, is it something that is nice to think about, or is it going to really become a reality? I know in some countries, I mean, things are already happening, but do you see this further developing in the years to come?
Yes, it'll have to. It's a difficult question because there's so much conventional transport liquids available, and you see the legislator, they are imposing certain amounts of biogenic fuels. These are FT fuels. These can be vegetable oils, ethanol. FT fuels are quite rare in the market at the moment. From biogenic FT fuels, they are quite commonplace already. FT fuels as such, they are quite commonplace, and we use them every day for those who use their cars. But it's not something that's, there are not a lot of biofuels or sort of second generation FT biofuels produced from biomass. And I think this is because the technologies are there, but it's expensive, and without real serious help from the legislator, it's going to be difficult, I think, to compete with the regular fuels, because there's the hydrocarbons that are available are still so massive. It's going to be difficult to have a head-on competition. So it'll have to become from the It'll have to come from the legislator.
Mhm.
I think there's no economic. If we do a business as usual, it's not going to happen.
Okay.
Because we have there's so much coal. If we use because coal to liquid technologies will be competitive with a barrel price of about 100, roughly 90, 110 dollars per barrel. So if we leave it as business as usual, at some point we'll stop extracting petroleum. We'll start using coal to liquid processes, which are exactly the same processes we use in biomass gasification and liquefaction.
Okay.
But it's yeah, I don't think if we do have a business as usual scenario, it won't work. But this is probably my personal opinion. There's a lot of shifts also going to electrification. So there'll be a reduction in the fuel consumption, of course, obviously over the years, because we go for electrification. But in the heavy transport industry, and it'll still be very important. So there's a lot of actors out there that produce different technologies on hydrothermal liquefaction, and a lot of people believe very hard in it. But the people working on wastes, and because there's also a reality that there's just not enough biomass to go around. I think if we have all the waste energy available in France, it doesn't represent 10% of the necessary energy needed for transport in France. So you have to be realistic. There's no way we can fuel our economies, the transportation in our economies with biomass. There's just no way. But that's not going to happen because we're going to shift our way of transporting. We're going to shift. We're going to enforce alternative ways of use of fuels. So it's something that will not be done by the market in itself, I think.
Okay. Yeah. Well, before we go to the next question, I mean, is there any comments or insight from other panelists? Yes, no?
Well, maybe I have a short comment. That I think that the waste disposal reduction can actively contribute to reduce the carbon footprint. We have measured through the LCA, the life cycle analysis, we have measured the reduction of the environmental impacts downstream. I mean, in the solutions we have suggested, but there is also an impact upstream in the waste generator in the pulp and paper industry, so they can reduce the carbon footprint also. I do not belong to the pulp and paper industry, but I've been working with them for the last 6 years, and I've seen an increasing interest in reducing the waste disposal, minimizing it at the minimum, and it is a question of money, of course, but not only. It's also important for them to reduce the carbon footprint and to increase the resource efficiency. So I see that this is going to take more relevance over the next years. And as David mentioned first, there are some other SMEs to fill the gaps, because obviously the pulp companies do not work for very specific solutions or waste management and so on, but there are a huge interest in some other SMEs to play this role. And well, that's all basically from my side.
Okay, thanks, Juan. Let's move to another question here. What do you think is holding back organization from adopting these secular business models? Is it about finance? Is it about disruptive technologies that are not there or that are not ready yet? Or is it about just the way the organization are thinking, and it's more about cultural mindset? Or is it about complexity of regulation? Or maybe it's just everything together? But what is the most important thing that is holding back organization from adopting the circular business models. I don't know whether Yasmina or Amaia, you want to start here.
Yes, I can start. Yeah, because when we were, well, within the paperChain project context, when we deal with the designing of the circular economy models, so we started identifying all these barriers in a close collaboration with the industry, with the partners of the projects. And in a broader sense, what we discover is that, of course, there are many barriers from different perspectives, as you have mentioned. And but what we discover is that a systemic perspective need to be considered to overcome all these barriers, to tackle with this. Overcome these barriers. So, but of course, as our audience has responded, the regulatory dimension is one of the most voted, and indeed in our project, it was one of the key block of barriers we discovered, and it is the most difficult to overcome and to tackle. And from regulatory aspects, well, I cannot go in detail in the whole barriers we discovered, but one of the key points was to obtain the declassification of waste, how the industry could obtain the approval of the end waste or the bioproduct categorization, and how they can valorize can use the waste valorized and used in construction sector, which is most of the cases are focused on construction sector. In this case, national and regional and European, at European level, the regulatory aspects are totally different, and there is a lack of harmonization on these regulatory laws, and also it takes cost and time to receive the approval from the authorities, and how the companies could offer this bioproduct to the end users, to the customers at the end. And also I would like to highlight, well, from economic perspective, of course, which is also one of the key building block regarding constraints to these circular products. So these circular products need to compete with linear product. These circular products are more expensive than circular one, and they have to companies developing this new secondary raw material have to deal with the reluctancy from the industry that is going to apply these new products. Of course, because they are reluctant to use recycled products or secondary raw materials. And so the initial awareness of the positive impact of the circular economy models restrict their adoption. And another one key point was related to the absence of green labeling to these secondary raw materials at EU level, which could help to overcome the market uptake of this bioproduct in the market. And finally, another key point is that in some regions and many countries, the landfilling remains too affordable. So in this case, it is really difficult to compete with traditional pathways of valorization, these kind of wastes. And maybe my colleague Yasmina, since she has been also involved in developing and discovering these barriers, maybe she can provide more specific detail about the circular cases involved in paperChain project.
Thanks, Amaia. Yeah, as you mentioned, of course, there are generic dimensions that we need to consider within this. It's a systemic view and approach we need to take. So technical, financial, innovation, regulatory and policy. So all of these really need to come together, and there's no simple answer. This is the main thing holding back. It needs to be a symbiosis, and all of these elements need to come together. And so, and of course, it's also going to be depending on the specific context, on the country, because also policies will change depending on the country context, but also depending on the solution. So as you could see from David's presentation, there was a lot of complexity in the different steps to be able to come to this circular solution, and very strong industrial symbiosis among partners to allow for this all of the technical complexities to occur, all of the quality standards to be met, a strong need for R&D to foster these innovations that take time. So there's really a need also to have that balance between the technical, being able to overcome the technical aspects, because of course, if the technology doesn't work, well, then nothing else matters. But of course, understanding that the business case has to stack up, the regulatory environment needs to enable it, and the partnerships need also to enable this. So I think it's really key that there are these supportive mechanisms, policy incentives, and it was mentioned before in the question, how is the pulp and paper sector going to secure funding to actually transform to carbon neutrality? I think it's quite clear that for some of this initial technology to be proven, there needs to be public funding, private funding, and to facilitate the green procurement processes to enable organizations to work together to develop these solutions.
Thank you, Yasmina. I don't know whether anybody wants to add something, or otherwise we go to the next question. Actually, I mean, you have presented your projects, and obviously, I mean, this result could help to overcome the barriers you mentioned, because we have learned a lot. You have learned a lot through your projects. But at the same time, you all say, well, there are barriers, that's obvious. So how your experience in the project and the result achieved could help overcome these barriers? You have identified them. How is it now going to be undertaken? I mean, we have this circular, let's say, economy objective. What are the strategy you, and maybe also with CEPI and others, we could adopt? What are the strategies we could adopt indeed to overcome these barriers, these problems? It can be at national level, it can be at European level, of course, because you understand, I mean, we cannot remain stuck with the barriers, the problems we have. We have to overcome this. We have to go forward. It's not an easy question, but I don't know whether Juan, José, you want to try to say a few things here.
Well, thank you, Bernard. I think as to my understanding, or after the learnings we have had from the project, from paperChain project, I think transparency is relevant. We have to call the attention of all the stakeholders to facilitate the overcoming of these barriers. The problems can be different from one place to another. Just as an example, we have a problem related with the public perception of using waste in Slovenia, for example. So transparency to communicate the results, long-term monitoring, showing the results of this monitoring. This helps to the people to understand that we can use secondary raw materials to be placed on the natural environment and nothing happens, nothing bad happens. So we need to publish papers, we need to participate in this type of events. We need to communicate the results at different levels. So this is relevant to push the public authorities to be aware of the benefits of this. Of course, we have detected some other type of problems in other places, but in other countries. But in general, it always has to do with public perception of different stakeholders. Sometimes it's the public administration, sometimes it's in other situations is other type of lobbies or organizations. But when you have a good solution, you need to try to convince all the stakeholders around to give up this reluctancy and to check the results. And of course, there are many things in addition to this, but this transparency could be one of the first movements to do.
Okay, Juan, thank you. I don't know, Yasmina or Amaia, I mean, is it really about this, being more transparent, more vocal, to communicate better about the barriers, convince and change the perception? Is it also what you have in mind as a strategy?
If I can start, maybe there were elements that came up from the analysis, the policy analysis that we carried out in collaboration within this project. And so it's just a reminder that I guess there are many barriers and there are many recommendations that we can make, but just to be concise, I think there were from this extensive analysis, perhaps 3 key points could come out of perhaps takeaways that we should put forward and work together as an industry and organize events like this today. You can see the 2 paperChain and Pulp&Fuel projects coming together, CEPI moderating. I think there are very key signals here, and we need to carry on with this partnership going forward to see how we transform the recommendations that we have put together and to actually share knowledge among the industry and see how we put them in practice. And so perhaps across the various dimensions that we cover, the 3 elements that really come out are the need for harmonization at the different EU, national, regional levels. Amaia mentioned before the issues of end of waste and BP byproduct declassification procedures, which are very different in different countries and which are quite a hard administrative burden, which make it difficult for companies to take on those new models. Having more common EU landfilling strategies, EU green labels and standards, common implementation of waste plans. So these are examples of really elements that need to be harmonized to facilitate the uptake of those solutions. Then another key point is around raising awareness on circular economy. And so this is also a point that was mentioned by Juan, but also before on the importance of demonstrating. So that these circular cases are being demonstrated and they showcase good practices of what can be done. And they also help make it a cultural shift in terms of what can be done within the industry and demonstrate that it's possible, it's beneficial for the companies involved in this, and they can also help the public administration see examples of places where it has been done to then also enable the processes to become easier by creating a new norm of what can be done. But then of course, this requires, and that's the third point, to build resources, and resources being financial, but also human. So we need to have, as I mentioned before, easier green procurement processes to facilitate the finance of these projects. But also we need to build capacity. People need to actually be trained. People need to understand the concept of circular economy so that this becomes more of the new business as usual needs to become circular. And so they need to be experts that can promote and connect. It can create this exchange of information and communication among the various stakeholders.
Yeah.
Thank you, Yasmina. I think we still have 2 minutes, but not more. I don't know whether Geert or David, you want to have a final word, or Amaia, but very briefly then.
Yeah, just to add that there are many barriers, of course, and how to tackle with them. But yes, just to add that maybe what we have discovered or learned from the project also is that how we can identify and transmit the global added value of the global value chain of all the stakeholders involved in this circular business model. This is one thing that I think it's really significant.
Good. Thank you. Geert or David, very briefly.
Yeah, I can be really quick, but of course, I spin on what Juan José said earlier, how the new products and materials are received in society is really, really important. And we have to be on a really high technical level on what we put on the market, because bad reputations, of course, is not something we want. So it's work through everything, be sure that we present circular material, bio-based materials that will perform as good as we hope and promise.
Okay, Geert?
Just like to add that we actually, from Pulp&Fuel point of view, we're probably we have to do more like a seduction, because we don't really have societal constraints, because we're not putting any more products in nature or outside of the plant. It's more in the paper industry is relatively conservative, and rightly so, because it's not so easy to just have a paradigm shift, or to just go from craft cooking to soda cooking. It's not something to be taken lightly. But it is possible to do small debottlenecking projects by diverting black liquor to alternative uses, such as lignin extraction or gasification. And these are possibilities that are not too complicated to operate. They don't produce any risk for the plant, and they allow the plants to on one side debottleneck, produce additional products, improve their image, and then of course talk to the legislator and say, okay, this is what we can do, but we need you to help us with the legislation to go further into this.
Thank you, Geert. Well, I don't want to take too much time as a conclusion, but I think what we heard today is that indeed, I mean, the pulp and paper industry is engaged in this long-term journey. It's about resource efficiency, carbon neutrality, closing the loops, bringing innovative products with low carbon footprint, be part of the circular economy, low carbon economy. It's a long journey, but I think we have heard your project, and we know, I mean, it's very promising. Okay, there are barriers, and they need to be overcome. We need the right regulatory framework. We need to invest. It's about technology. It's about perception also. That's also something I heard from you. So obviously, I mean, we have to communicate more and better about what we are doing, about the potential, about the opportunities. And that's only, I think, by doing this that we can achieve and meet our targets. But now it's high time for me to close down this panel. I want to thank the panelists and all of you for staying with us for this very inspiring discussion. I must say I've learned a lot also. Once again, thanks a lot to all of you. You will receive shortly a follow-up message with all the presentations and the recording that it will be available. If you have any last question, you can send them to us and we will do our best to answer them. Thanks a lot and bye-bye. Thanks.
Okay, thank you.
Thank you very much.
Okay.
Goodbye.
Thank you very much.
Bye.
Thank you.
Thanks. Bye-bye.